Good morning, students. This is the seventh and the last lecture in the series of hydraulic turbines. Okay. In this lecture, we will study about the description and working of a draft tube. Okay. We will also study its function. Okay. Now, in the case of an impulse turbine, okay, that is Pelton wheel turbine, what happens is the whole energy, fluid energy, or the energy of the flowing water gets converted totally into kinetic energy. Okay, and it is when the jet strikes the bucket, the total kinetic energy is utilized. Okay, so the efficiency or the head loss that occurs in a Pelton wheel turbine is 1 to 4%. That means there is only 1 to 4% loss in energy or the kinetic energy in a Pelton wheel turbine. But in the case of mixed and axial flow turbines, a large portion of the energy is associated with the water as it leaves the runner. Okay. Now what is its meaning? Okay, we'll see. Okay. In the case of mixed and axial flow turbine, that means in the case of Francis turbine and Kaplan turbine, okay, there is a spiral casing along the turbine through which the water enters. In the beginning, the area of the spiral casing is large. That means the pressure is large. Okay, and at the end of the spiral casing, the area decreases. It is the minimum. So there, the pressure energy is minimum. Okay, now what happens in the case of Francis turbine and Kaplan turbine? Okay, uh, there is not just kinetic energy which is acting. Kinetic energy and pressure energy both are acting. Okay, now the kinetic energy gets utilized totally, okay, for running the runner blades. Okay, and the pressure energy which is there, it gets converted into kinetic energy, okay, at the end. Okay, now we'll see how that works. The exit energy varies from 4 to 25% for mixed flow turbine. That means the energy loss at the exit for mixed flow, that is Francis turbine, is 4 to 25%, and for Kaplan turbine it is 20 to 50% exit loss in energy. As this energy cannot be used in the nano, therefore it becomes necessary to find a way how to extract this energy. Okay, the energy which is lost at the exit, it cannot be converted back into and used in the runner. So we have to find out a way to extract this energy. So how do you do that? We use a draft tube. What is a draft tube? It is an expanding pressure conduit fixed at runner outlet and having the other end below the minimum tailwater level, helps to convert the velocity head into pressure or potential head. Okay, now we'll see the diagram. These are the diagrams of draft tube. This is a conical draft tube. Okay, this is known as elbow draft tube. This is also an elbow draft tube. But this elbow draft tube number 1, this elbow draft tube number 2. Now in the elbow draft tube number 1, the inlet, okay, inlet shape is circular and outlet shape is also circular. But in this case of elbow draft tube, inlet shape is circular and outlet shape of the draft tube is rectangular. Okay, and this is the Moody spreading draft tube. That means inlet is one while there are number of outlets. Okay, now at the exit of the runner, okay, when the pressure energy has been converted into kinetic energy, okay, there there is, at the exit there is a lot of energy left, okay, which gets lost. Okay. Now what happens here? Due to low pressure, kinetic energy will be high, but as we'll provide a draft tube, that means a tube with increasing diameter or increasing area, that kinetic energy will get converted into pressure energy. Okay, if you see here, as the area increases, the kinetic energy will get converted into pressure energy, and that energy we can utilize for the creation of electricity. Okay, we'll see how that is done. Now, draft tube is an integral part of mixed and axial flow turbine, that is of Francis and Kaplan turbine. Because of the draft tube, it is possible to have the pressure at runner outlet much below the atmospheric pressure. Okay, the draft tube serves the following two purposes. It allows the turbine to be set above tailwater level without loss of head to facilitate inspection. And second, it regains by diffuse action the major portion of the kinetic energy delivered to it from the runner. Okay, so what happens? We'll see the second point. It regains by diffuse action the major portion of the kinetic energy. Okay, the kinetic energy at this point here will be provided by the runner. Okay, now if there was no draft tube here, all that kinetic energy would be wasted. Okay, now but due to draft tube, what happens, this kinetic energy is converted into pressure energy because of the increasing area. That kinetic energy gets converted into pressure energy, and hence that energy is also utilized. Okay, it does not go waste. So these are the two functions of the draft tube. Okay, first is second is what, it converts the kinetic energy into pressure energy, and hence there is no loss in energy. And second, it allows the turbine to be set above tailwater level without loss of head to facilitate inspection and maintenance. Okay, so this is the end of draft tube. I hope you understood it. Thank you.